All right. So we found the mass of copper oxide or copper 2 oxide. Now we're doing math on combustion analysis. So I gave you this worksheet. Did everyone grab one off the back table? Did I run out? All right. So everyone have one? Thumbs up if you do not have one. All right. So everyone has one. This seems like the hardest possible way I did that, but whatever, the job is done. Okay. Yeah, oh, you did? Yep. All right, this paper, you do not have to turn it in. It's just some instructions. Instead of having you take time to write them down, I typed them. And then I have 5 example problems. Easy enough. Okay, here we go. So, just real quick. A picket fence can be used to determine the amounts of an element in a formula, as well as grams or moles or anything like we've done. So this is because the formula of a compound is giving us the molar ratios of the elements involved. So for instance, if we have CH3 stuck to something, it tells me I have 1 C for every 3 H's. We okay with that? We can use a picket fence and say, all right, if I have a compound right here, how many grams of oxygen are in 2.58 grams of NO? Don't write this down, but we can do it this way. We have 2.58 grams of NO. We would find the molar mass of NO. That's 16 plus 14, so that's 30 grams of NO for every 1 mole of NO. Now, we're not solving for any other reactant. We're just finding out the parts that are involved here. So for every 1 mole of NO, I have, it wants oxygen. I have 1 here and 1 here. So 1 of NO. Or sorry, that's just an O of O. For every 1 mole O, I have 16 grams. So I could find out how many grams of just the oxygen there are in my NO given an amount. Now you could do it a different way, a percent composition and multiply it. That works too. But this, just kind of stick with this example as we talk about what we're going to do. Okay, so combustion analysis is a scientific principle where we don't know what something is, so we light it on fire and see what happens. That's literally it. All right, so what we have a sample, and you don't need to draw this. We have a sample in a furnace, we light it on fire, and then we have the products go through these copper 2 oxide, sorry, a water absorber, a carbon dioxide absorber, and we measure the difference in mass between these 2 things. And that will tell me how much water was produced and how much carbon dioxide was produced. Okay, now, it's really genius if you think about the following. Any hydrocarbon, so like CXHY plus O2, we know it produces CO2 and H2O. You okay with that? What's really smart is the amount of carbon in carbon dioxide is directly related to the amount of carbon present in the first place. And the amount of hydrogen present in water is determined by the amount of hydrogen present in the compound in the first place. So I don't know how much of this there is. I'll know the grams, but I don't know its ratio. All right, but I do know these 2. So I can use what I do know to figure out what I don't know. Okay, the ideas behind it are kind of really smart. So once again, we light it on fire, measure the amount of water absorbed to find how much H there was, measure the amount of CO2 absorbed to figure out how much C there was, and then we're off to the races. There is a problem, it becomes harder when you have, this was supposed to be a Y, not a 4. If this has an O in it, O O is a lot harder to calculate because oxygen in the hydrocarbon, it's here, but it also is here, and it's here, and it's there. So oxygen's everywhere. So we'll talk about it, but what we do to find it if it has oxygen is we find out how much C there is, how much H there is, and subtract that from the initial mass of CHO there was. And then that tells me how much O came from just the original thing. You're like, wow, I understand everything he's saying right now. If you're in that boat, congratulations. Most of you are like, what are you talking about? Well, let's dive into it. It's really not that bad. All right. So this is from your notes, I think. Combustion analysis takes advantage of the fact that the combustion reactions always produce the same products. By accounting for the mass of CO2 and H2O produced, we can use stoichiometry to calculate the moles of C and H in the original hydrocarbon. Okay, that's what we're going to do. We're going to do it over and over and make it complicated, of course. All right, there are two ways to solve this problem. Steps when there is no oxygen in the hydrocarbon. Well, that was weird. That was supposed to be a whole line. So when you are told in the problem that there is not oxygen in one of these, you follow the following steps. And they're really, really simple. These can be done in under 2 minutes. Now, we'll do it the longer way, but we'll show you. So it says, use the given mass of CO2 to calculate the moles of carbon. And this says, just right here, whoops, that's what I want. It says divide by 44. We'll talk about why in a minute. Use the given mass of water to calculate the moles of hydrogen, and that says divide by 9. And we'll talk about that. Divide the two answers above by the smaller of the two answers. That sound like Friday? Okay. These things are going to calculate moles. Dividing moles by the smaller of the two gives you the ratio of moles. And the ratio of moles gives me the formula of the compound. Okay. Use these answers as the subscripts to go with C and H in empirical formula of the hydrocarbon. Asterisks, and that asterisk is going to be covered in a minute. If a molar mass is given in the problem, you must make sure your empirical formula adds up to the molar mass. If it does not, you need to multiply each, I don't know why that's there, each subscript by a single factor to get it to match the molar mass. Okay, I see a lot of looks that usually don't exist till the last 5 minutes of class. Could be in trouble today. Could be in trouble. It's probably my fault. All right, we will come back to what to do if oxygen is. It's a lot longer problem time-wise if oxygen's present. So let's do number 1. Oh, the asterisk, I guess. It's in your notes. It says, if dividing each answer by the smallest answer does not yield a whole number, you need to multiply each answer by some number to get them to whole numbers. So this is Friday. We said, hey, if we do it and you do all the math and it's 1, and then the other one is 1.5, this is not a whole number. So you got to multiply both of them. And you get C2H3. Okay. So if it's not a whole number, we multiply it to make it a whole number. All right, that's what that asterisk is. And once again, that makes things quite a bit harder. 1 or 2 of these has that, and the other ones don't. Okay, and number 1, you with me? Try not to give up today. You'll need a calculator. If you want to get one besides your phone, grab it fast. They're just right here. Bless you. I'm driving with Adelaide today. Am I going to survive? I'm driving with Adelaide today.
You got to be careful. Might,
I'm ready. Okay.
pay attention.
We'll see. All right. All right, let's work through this together. I'm going to follow the directions. I don't have them in front of me, but I'll look off my lab partners. So first off, this one doesn't say it, but there's no oxygen in number one, which means this one's an easy one. But stick with me. Step number one says to do what? All right, use the given mass of CO2 to calculate the moles of carbon. I'm going to do that in a picket fence, but then you'll see why I say divide by 44. All right, so I want to take the grams of my carbon dioxide and find the grams of CO2. Well, I'm going to show you two picket fences, but these will end up having 0 picket fences. Just trust me. So you have this many grams of CO2, 0.845 grams CO2. Now I want to solve for grams of carbon. Wait a minute. This one I want to, the moles. Moles. Sorry, I wrote grams. That's what I'm looking for. This is moles. This is moles. You'll see why I went to grams in a minute. So I want just moles of carbon. Down here, I want to solve for moles of H. Okay, now follow along. Picket fence, we know whatever's here goes here, right? Grams of CO2. And going way back in time, grams is always tied to what other thing? Good, 1 mole of CO2. Now, this is where I would find the molar mass of CO2. If you add it all together, you get 44 grams. It's like 44.00 something, whatever. It's 44 grams of CO2 per 1 mole. You with me? Okay, what comes down here? All right, so for every 1 mole of CO2 in this formula, how many moles of C are there? That's a hard question for some. It's this unit. Oh, that's supposed to point right there. There's just a 1, right? We don't write it. But for every 1 CO2, there's really 1 C. Okay, now this is the picket fence. This is the right way to do this. But math, what's the only thing we're doing? We're dividing by 44 grams. Everything else number-wise just cancels out. So on your instructions where it said in the first thing, just to divide by 44, this is why. It's because in the picket fence, everything's eliminated except for 44 in the denominator. Okay, does anyone have that number for me? Oh boy. 019? Okay. Oh, yours is different right here, isn't it? 0.346?
Yeah.
Sorry, it's fine. Yours is that way. This one, I changed it after I cut it. Okay, now coming down here, I use the grams of water, which is 0.346 grams of H2O. So what must come down here? Grams of H2O. I find the molar mass, and it's 18 grams per every 1 mole of the same thing. Okay, now what comes down here? Tell your partner. All right, good. Mole of H2O. And for every 1 of those, how many H's are there this time? There's 2 of them. Okay, now in the piece of paper, the instructions said to just divide this by 9, right? And that's because this picket fence, all of this is just really 1 over 9. You with me? Okay, so I take 0.346 and I divide that by 9, and I get what number? 0.0384. Okay. Then, once I have moles, I'm to where I've been before. The instructions say divide both by the smallest answer, which is 0.019 and 0.019. The first one's easy. That's a 1. This one's pretty easy. It's a 2. So the empirical formula of this substance is just simply 1C to every 2 H's. All right. Now, my friends, let's pretend again. Let's say this was equal to 1, and let's pretend we did this. This is pretend land. It's not real. But let's say it was 2.25. Will you reach back and look at that little asterisk in our notes and tell your partner, what would you have done if it was 2.25? Awesome. All right. Good job, Sky. All right, my partner just simply said, hey, I'd multiply it by 4. Who's with us on that? Okay, you multiply it by 4 because 0.25 is 1/4. So if you did the math and it was this, you'd multiply both things by 4 and you'd end up with C4H10. Okay, all right. The second one, a previous analysis determined that the compound does not contain oxygen, which means you do everything exactly the same as we just did. You can do the 2 picket fences, or you can use the short numbers. Okay, ready? Have fun. I'll give you 3 good solid minutes to work on that. Looks like it was Blaine's turn to come instead of Samantha's. All right. Fantastic question. Are these numbers going to stay the same? That's the only nice thing about combustion analysis is we're always doing the same picket fences. So since they're always the same numbers, those things will always stay the same. All right. I didn't look at my clock. I was distracted. I think we're 1 minute in. So you still have a couple. All right, Samantha, I just emailed you through Canvas the piece of paper we're using today. All right, as you guys wrap up, check with your lab partner. What? This one you do have to do some stuff. Well, you're just multiplying it by the wrong number. 0.4. 4 times what will equal a whole number? 5. So it's my 5. All right. You are welcome, my friend. That was to you, Sam. You're welcome. Okay, here we go. Well, raise your hands if you have an answer. You have the right answer, by the way. Okay. The answer should be C5H12. Who has that answer? Raise their hands. Okay, kind of tricky, but the overwhelming majority of you got it right. So for those that didn't, I'm going to do it the non-picket fence way. It still is really the picket fence way. I'm just not writing it down. So I have 38.196. And I divide that by what? 44, correct? And then I got 0.868.
Yeah.
Okay, then I had 18.75 and 2, whatever, that didn't make sense. Divided by 9, and I got 2.4. No, sorry, 2.08, right?
Yeah.
Who gave me a what? All right. The next step was to divide both by the smallest number, correct? And I got a 1, and then I got a number that didn't really make me very happy. It was 2.4. And I can't just round that like, oh, that's a 2. And I don't want to round it to 0.5. That's not good either. So I have to think in my head, what number times 4 will equal a whole number? And it's 5. 5 times 4 is 20, right? So I multiply both of these by 5. So C5H12. That's where that came from. Okay, who's with me? Good. Next. Oh, I changed this one too. I added the sentence that this one did not have oxygen, right? Okay. Okay, take another couple minutes. Same process. Same process. No oxygen in this one either. Yeah. Yep, it is just the same thing. That's the only nice thing about combustion analysis is they never change the process. All right, my friends. I'm not going to give you the answer. I'm just going to tell you something that I did here and that the AP test really likes to do to you. And it's to give you stuff that doesn't matter. In this problem, the very first thing right here in this example doesn't matter at all. Do we need the amount of oxygen required to have this reaction happen? No. So it's there, that's great, but don't fall for it. Hey, well, Payne found a misprint on the other ones. If you go ahead, we'll fix it, but not a misprint. I just am an idiot. Okay, who has this one answered? The answer to number 3. Raise your hands if you're done with it. Okay, who has C5H8? Okay, so without oxygen, raise your hands if you're comfortable doing these without oxygen. You guys already moved on, so I'll assume your hands up. That's pretty much 100% of you. On the exam, there's one without oxygen and there's one that is with oxygen. And the exam's on Wednesday, so it's definitely time to care. Well, I'm not going to start the unit and then have like one day in a spring break. So we might as well do it the last day before spring break. Fall break. Thank you. Fall break. You're welcome. Okay, number next. Are we ready? This is where the fit hits the shan. All right? It gets harder. Don't rearrange it. Here we go. If there is oxygen, life gets trickier. There's more dots. Oh no. So use the given mass of CO2 to calculate the grams. The grams. Now be careful. This one's grams. Next, use the mass of H2O to calculate the grams of hydrogen. The third one, add the C and the H together. So you're adding these two answers. You add them, and that's what you're doing in this. And then subtract that number from the original mass given of the hydrocarbon to find the mass of oxygen. It's tricky. If it has oxygen or nitrogen or phosphorus or sulfur, we can do this for whatever we want. We have 3 parts. We know 2 and we know the total. So you just subtract to find the third piece. Okay, next bullet. Convert the C, H, and O grams to moles by dividing by their molar masses. Now, you kind of already did it and then undid it, but just trust me. Divide the 3 answers above by the smaller of the answers. This, you can get rid of that. It's just the same thing we did before, but we have 3 now. Of the 3, one of them will be smaller. Divide them all by that value. Okay, use these as the subscript. If it's not a whole number, we got to multiply. And then if a molar mass is given, you have to make sure it adds up. So we got more steps here, but we can do it. Okay, really encourage you to follow the directions very explicitly. So we're going to use the given mass of carbon dioxide. Oh, look right here again. There is a huge time saving. There's those 2 shortcuts. And I'll show you where those come from. But I would definitely memorize these or program them into your calculator. 0.2727, that goes on forever. And 0.11111, that goes on forever. You'll see why. Okay. So here we go. Whoops. Uh-oh. Why are they out of order? That's bizarre. Okay, number 4. Here we go. A 2.5 0.5 gram sample of an unknown alcohol, now it says it's CHNO, was burned. 0.56 grams of CO2 and 0.306 grams of water were produced. What is the formula of this alcohol? Okay, what's that? Well, it's in grams of CO2, but I need grams of C and grams of H. Who's with me? Okay, now I'm going to do 2 picket fences again, but it's exactly like last time. The picket fences will eventually go away if you like it that way. So I'm going to use my grams of CO2, 0.561 grams CO2, and I'm going to solve for grams of C. All right, so I'll set my picket fence up here. I got to get rid of grams CO2, so I put 44 grams of CO2 right here. Grams is per 1 mole of CO2. Down here, 1 mole CO2. Up top, 1 mole of C. Down here now, 1 mole of C is 12 grams of C. If you will, all those of you that are paying attention, this piece of the picket fence is always the exact same. So we could write it out, or we could just take 12 and divide it by 44. Will someone do that for me? Oh, it's 272727. Okay, so this piece of the picket fence is 0.2727 forever. If you look at the instructions right here, right there. So if you want to save time, which you should do, you take the grams of CO2 and multiply it by 0.2727. Okay, coming back. We're going to do the same thing with the grams of hydrogen. Whoops. I have 0.306 of H2O, 18 grams H2O, 1 mole, H2O, 1 mole, H2O, 2 moles of H, 1 mole, H, 1 gram H. All right, same lecture as before. This piece of the picket fence is always the same. And honestly, it's the same as the moles were because the mass of hydrogen is just 1. So this tells me the grams of H. All right, I did it before and I got, is this the right one? Yeah. 0.1530, is that okay? Is that what you guys have? And 0.03396, is that one? I'll just say 0.034. Everyone okay with that? Who's with me? Did I have those numbers right? Okay. Now, there's a lot more involved. The next step in the instructions tells you to add these two together, right? All right, because remember, I don't know the mass of oxygen because the mass of oxygen would have come from the oxygen required to combust the alcohol. Okay, so when I add these, has someone already found that number? 0.187? All right, so stick with me for a second. What we just solved for in my hydrocarbon, 0.187 is the grams of the carbon and the hydrogen. Thumbs up, is that okay? I solved for grams of each and then I added. Okay, so to find how much oxygen there is, I take the total I started with and subtract the C and the H. So the total I started with was up top 0.255 minus 0.187. 0.068, is that right?
Yeah.
Okay. All right. Now, a lot of kids screw up right here. Any guesses what you do wrong? You think you're ready to divide by the smallest number. But we can't do that till we're in moles, right? It's very tempting because you're like, oh, look, this is half of that. I know what I'm doing. We got to divide by moles or convert them to moles first. So this step, now that we have the grams of all of them, we divide each by their molar mass. Uh-oh, I can't lose you. Where did I lose you?
Oh, I actually divided by the molar mass of CO2.
Okay, okay. Okay, now, I'm going to bring them down here. So moles, C, moles, H, and moles, O. It's the answers to these. So H is easy. It's the same. It's just 0.034. But moles of carbon, I had 0.153 divided by 12. I get 0.01275. Is that about right? Okay. Whoops, sorry, that's supposed to be here. And then moles of oxygen, 0.00425. Anyone back me up on that one? Okay, now, most of you probably have numbers that are slightly different, right? It's all about whether you kept the numbers in your calculator or not. But they're probably, hopefully, very close. Okay, now, these are moles. Once we have them in moles, then we're in an area we should hopefully be comfortable with. What do we do once we have them in moles? Divide them all by the smallest number, right? Pretty sure. Okay, when I did it earlier, I got a 3, an 8, and a 1. The 3 was like dead on. The 8 was really 7.97 or something like that. No? Easily? No? Okay. So these all combine to be C3H8O. Now here is the problem with these problems. One tiny mistake and it's a disaster. Like mega disaster. I'll end up with answers on the test that are no joke. They're like C57, H185, O. You get that, you did it wrong. Don't try and redo it because it's like another half hour of your life. But it won't be crazy. It won't be crazy, but if you make the littlest mistakes, you end up with the biggest problems. And it's a pain. They're not difficult because any specific part is very difficult. They're difficult because there's so many things. Now, if I were you, most of the time you do this, I would write 4 digits for every number that aren't zeros. That will get you as close, pretty close. If you round and you give me like, let's say it's 0.34, and you just round to 3 at the start, you're going to be so far off at the end. It's not even, it's crazy. You'll end up with a 57 when it should have been a 3 because you rounded real early. So give yourself at least 4 non-digit zeros to ensure you're pretty dang close. Okay, now this problem, this was different on yours. I rewrote it, but it says the mass is around 180, right? Okay, so one more layer of stuff. The mass should be 180 grams per mole. Has anyone already added this up? If you take 3 times 12 plus 8 times 1 plus 16, if I remember right, you get 60. Okay, is 60 180? No. But if I multiply it by 3, is it 180? Yes. So all of the subscripts now get tripled. So C9, H24O3. This equals 180 grams per mole. This was only 60. So let's review some terms. This right here is called the molecular formula. That is its truest formula. This is called its empirical formula, which is the lowest ratio. This is a lot. I am 100% aware of that. Okay. Quinone, or quinone, however you want to say it, which is used in the dye industry and photography, is an organic compound containing only C, H, and O. There's your stuff. Have fun. This one has smaller subscripts than the last one. All right, with me for the last 20 seconds. I will put, please, I'll put a practice one and the answers on in the announcements. Is that working that way good enough? In Canvas?
Oh, in Canvas?
In Canvas. I can put it on the GroupMe too. Both? Okay. Sounds good. All right, you guys are amazing.